MODO is an exceptional, universally recognised polygon and subdivision surface modelling application. Built on a philosophy of tools that enhance creativity, its toolset is mature, fast and easy to understand. The majority of tools in MODO are a combination of building blocks, transforms, action centres and fall-offs, which together make more powerful tools. Action centres, or custom tool pivots, are a set of modifiers that allow you to change the position at which a tool will operate, and also how the tool handle should be aligned. Fall-offs are methods of modulating the effect of a modelling operation, and remain live while the tool is running, so deformations can be intuitively tweaked. Most importantly, MODO allows you the freedom to combine these elements yourself. The result of this is a small default toolset, but with the potential for an almost limitless number of variations. What those variations are is up to you. The work plane is a 2D plane upon which all tools will operate, and it's adaptive, so it will predict which plane you wish to work on based on how you're looking at your model. Tools will always work across the active plane, allowing you to accurately model in a single 3D viewport, and reducing the need to work in a more traditional quad view. You can also align the work plane to any part of your model, and the whole tool system will respect that change, allowing you to work locally at any point in your scene. If you drag and drop an image into the 3D viewport, it creates a backdrop item, an image plane that you can use as reference. You can create as many of these items in the scene as you need, allowing you to create very sophisticated reference structures. Models in MODO can exist in any combination of 3 polygon types: faceted, sub-D or P-sub or Pixar subdivision surfaces. Faceted polygons can be easily toggled to sub-D or P-sub on the fly, allowing you to move between polygon types at great speed. Which polygon type you choose depends on what you're making, allowing MODO to be used for a variety of modelling tasks. For example, P-sub allows you to perform edge weighting with no UV distortion, which is particularly useful for either design or VFX-focused hard surface modelling. Snapping can be toggled on and off on the fly as you're working, which means it's available to you whenever you need it. You can define a set of global snapping behaviours along with a set of component and item-based behaviours, and MODO will automatically change to a defined set based on which selection mode you're in. Multiple snap types can be active at the same time, and snap types will also respect action centres and instance geometry. Selection is a joy in MODO. Components can be paint selected, loop selected, pattern selected, moved, expanded and contracted, inverted, lasso selected, and you can even select one side of an object based on how many polygons are on one side of a polyloop. When you're modelling, selection is something you do more than anything else, and in MODO it couldn't be easier. One of the most powerful features of MODO is its polygon editing tools. These allow you to intuitively slice, slide, bridge, extend and extrude geometry with ease. Many of these tools preserve surface curvature, and best of all, the bridge tool will automatically create and weld the correct number of edge loops to fill any gap. Rebuilding models from scanned, sculpted or CAD data is a common task in both VFX and design, and is made possible in MODO by its robust constraint system. When active, it will force tools to operate on the surface of a background object, allowing you to create and slide geometry across the surface of another object, or even project geometric shapes onto it. Many tools use constraints by default. For example, the topology pen allows you to move, extend, slice, slide and delete elements when building a surface on top of another object, and along with the contour tool, which helps you to quickly bridge tubular elements of an object, forms the backbone of a powerful retopology toolset. When modelling certain types of objects, you often need to undertake repetitive tasks. In MODO, you can use a macro to record your actions. You can then save it to your system config or to a separate file on disk, and then rerun it via a hotkey or UI button, speeding up your work considerably. One of the most impressive features of MODO is how it manages model complexity. The basic duplication tools allow you to either clone an object along a curve, around an axis, or to a grid, as well as being able to paint geometry onto another surface. But for each of these tools, you can also create instances and replicas. Replicas are objects that are instanced to a point cloud, which you can then apply random transforms to. They allow you to have incredibly large numbers of objects in a scene with little impact on scene size. The point cloud could be generated manually, via the duplication tools, derived from a polygon surface, or applied to a material, which allows them to be modulated by textures and weight maps. In a modelling context, you can manipulate replicas by manipulating the point cloud. For this reason, MODO has a set of dedicated particle sculpting tools, which allow you to paint and deform particles. And by using vertex maps, you can also rotate and scale points, which gives you an incredible amount of control over a replica's position and orientation. Replicators impact on various aspects of MODO, not just modelling. The perfect tool for creating complex ecosystems, and like so much of MODO, a great example of a tool that's beautifully embedded across the whole system. MODO is a tried and tested modelling application used in a variety of industries. Its intelligent design allows the creatively minded to easily explore and exploit what it has to offer.